The last type that we are looking at is the time, well, not the last type. The next type we're looking at is time delta objects. They store the duration between 2 points of time. So we've already seen examples of that. And what we can do is we can, given that we have the start of the century here, in century start, we've got the time now, which is a date time object, so it has date as well as time. We can print the number of days by just extracting that attribute. We can get the total seconds. This is going to be a little bit different from just doing seconds, because seconds will tell you the number of days and the number of seconds for that day, the extra that is over and above, like 600,338 days plus so many seconds. Whereas total seconds will tell us the total number of seconds from the beginning of the century to now. So that's the total number of seconds from the beginning of the century to now. If you want to convert it into minutes, then we can divide that by 60. If you want to convert it into hours, we can divide that by 60. If you want to convert it into seconds, into days, we can check that. We already have days, but we could divide that by 60 as well. And if you want to convert to years, it's a little bit complicated, because if you divide it by 365, then you're going to be messing up in terms of leap years versus non-leap years, 365 days versus 366 days. So you need a little bit of a complicated calculation, and there are other libraries that deal with this as well, but we're not going to worry about that. Okay, so that's what we can do with time deltas. And the fourth kind of object is a date time object. Time object is a time of day that is disconnected from the date itself. So let's take a look at this here. So we have the now gives us the date and time right now, and then we can extract from this the time part of it. The time part is going to be just the time without the date attached. So this is 10/28/06.130552. This is sort of useful if, for example, you're looking at daily data and you want to find the, let's say you want to bucket the times, and we will do an example like that, so that you want to see what is the passenger flow between 8 a.m. and 9 a.m., between 9 a.m. and 10 a.m., etc. In that case, you don't care about the day as much. You're not concerned whether it's January 1st or January 10th or whatever. You're just concerned about the time aspect, so you can get rid of the date completely and use the time. And then that's really when you use stuff like this. So that's when maybe bus schedules. If you're writing an application that contains bus or train schedules, then again, you don't care so much about the day, you just care about the arrival and departure times. So those are our 4 data types, and we can do arithmetic operations on all this stuff here. So for example, if we have, we can add to time delta to a date or a date and get a date or a date and time to get a new date and time. So here, for example, we've got the day of today, which is sitting in a variable called today, and we can add a date time delta object to this, which says 5 days. So we're going to add 5 days to this. So this tells us here that today, actually the day that I'm doing this is the 9th of May. Let me just put that in there. So that's today. So it's 9th of May. So 5 days later is the 14th of May, and we've added that to that. So that's good for when you want to make calculations on time inside your application or analysis. We can do the same thing with date time objects. So here we have now is date time.today. Today is the same as now. And then we can add 5 minutes, 5 seconds later to that. So we get this here. So what we're saying is we want to add 5 minutes and 5 seconds to our current time, which is this variable now. And then we get 5 minutes and 5 seconds later, which says, this is of course right now it's 10:35. Let me add that back here. Now, so it's 10:30, and this has now become 10:35. So that's, we can do that. We can look at the difference. We've already seen that. So there's another example. So this is now, and we can get 5 minutes and 5 seconds earlier, and that tells us that 5 minutes, 5 seconds earlier was 10:25. It's 10:30 in the morning right now. However, you can't use time delta on time objects, and if you do that, you get what's called a type error exception, and there's a good reason for this, right? But we'll come to that in a second. So let's say we've got we're looking at the time now, and we're extracting only the time element of that, right? So that's what we get here, time now, which is just the time element of our time. Then we want to take that time. So let me run this, and so that's the time that is right now, right? And we want to now add 30 seconds to that. So I create a time delta object called 30 seconds, which is a time delta object, and seconds equals 30. and I do time now plus 30 seconds. And what I get is a type error. It says you can't do that. You can't take a datetime.time object and add a time delta object to that. There's a good reason for that if you think about it. Is it a bug or is it a feature? So it's actually turns out to be a feature, because if you think about it, let's say you're flying from New York to let's say to Yangon in Myanmar. Typically you would leave New York at about 8 in the evening, and on day 1, let's say on the 10th of May, and you would arrive in Yangon in sometime in the morning of the 12th of May. So if you have time objects, you would say I'm leaving at 9 p.m. and I'm arriving at 7 a.m. But you're actually arriving at 7 a.m. 2 days later, and that's not captured in just pure time objects. So therefore, within Python itself, the decision is we will not allow time delta calculations on time objects, because there's this confusion as to whether you've crossed more than a day or not. Right? It could be a problem. Therefore, for consistency and making sure you're always getting the right answer, we don't allow that. But of course, this is Python, so you can always write a little function that does that. And you've got to get used to this. When you're doing data analysis, you're going to write lots of functions. So we write a function called add to time that takes a time object, takes a time delta object. And what we do here is we just create an artificial date. So this is the year 500, the January 1st of the year 500. And we add that into our create a date time object that takes that and takes the hour, the minute, and the second from our time object and constructs a new datetime object called temp datetime object. And then what we do is we add the time delta, that is the time, the time delta to the new datetime object, the temp datetime object, and return just the time component of that. So this is the new object that we are creating, and from that we just returning the time component, and that will pretty much do it for us. So we now get this stuff here. Of course, keeping in mind that we will have the same problem that if we span more than a day, then our application is not going to capture that. We could force it to do that if we wanted to, but we are not doing, our function is not capturing that. We could force it to do that, but we are not doing it. Then the next thing we want to do is that if we have datetime objects, typically you're going to get the date and time from some kind of input device, either a file or from a web page, or someone is going to enter it. So whatever data that you get is going to come in the form of a string. Since it's coming in the form of a string, you need to convert it into a datetime object to be able to reason, to be able to reason with that time or date or whatever. So since you're getting that as a string, we need a way of converting it. And there's a very nice library called strip time, or a function called strip time, strp time here, that does the conversion for us. So if you go to this website over here, and let me just see if I can do that without messing anything up. Yeah, I can. This shows us that we have various formatting codes for each type of date or time. So for example, here it says if you have %b, then that's the month using the locale's month name, which may be abbreviated or full name. So you might be able to do something like APR-01-01 for 1st April, APR-01-2001 for 1st April 2001. So what this is saying is that you can use APR or April if your locale, that means your computer locale, is defined as an English-speaking locale. If it's some other language, then it would be whatever the abbreviated or full form of the month is in that language. So there are various formatting stuff. So we'll take a look at how to use these. So let's say we have a date here that is 01 APR 03, right? So that is 1st April 2003. So the codes that correspond to this are %d, which is the code that says essentially the day of the month with or without a leading 0. So either 1-APR would work or 01-APR works. %b, which says, we just saw that, that's your code that says you're going to use the name of the month in the language of the location where you are at, or where your computer thinks you are at, whatever you're defining. If you're using a Spanish computer, for example, then it's going to use Spanish names. And then 03, which is %y, which says that you're going to use a 2-digit year, and or a 4-digit year, actually, either is fine. And if it's 2 digits, then it's going to use a code where it says if the date is, I think, if I'm not mistaken, past 1966. Let's take a look at that. %y. So it says here the year within century. When a century not otherwise specified, so in our case it's not specified, then the values in the range 66 to 99 shall be from 1969 to 1999, and anything from 00 to 68 will refer to the years 2000 to 2068. Okay, that's the way it does it. So obviously, if you once you hit 2068, we're going to have a problem. So we are just sort of pushing the problem into the future if we do this, but often that's what you get. You have to work with the data you get, right? So often that's what you get. So let's assume that's what we get here. So here what we can do is, so we specify the date in a string format. So this is our date, 01 April 03 in string format. And then we give a formatting string after that. The formatting string tells us what kind of format this variable is using to represent the date. The string, what kind of the string is using to represent the date, and so that has to correspond to what this is. And notice we have dashes over here, and the dashes correspond to whatever was there. All right. So if there was a colon, then that should be a colon. If there's a slash, it's got to be a slash, or whatever. Right. So this is the exact format, and this we run this, and it tells us that we now get a date object that is giving us this date time object actually, because we're using the date time object here. It's telling us it's 2003 0401 000000. So that's strip time, and we'll take an example further down that'll do a little bit more with that. So unfortunately nothing there for time delta, so you can't take time deltas and convert them into that in the form of strings and convert them into a time delta object. So what you would need to do is you would need to write your own function for it, or do the conversion explicitly. In this case what we do is we say, all right, our string is hours colon minutes colon seconds, therefore we're going to extract the three elements, the hours, minutes, and seconds, using the split function, split on colon over here, right? We can see that it's splitting on colon there, and then construct a time delta object by saying the hours are the hours, the minutes are the minutes, and the seconds are the seconds. Notice that we use the unpacking assignment here to extract each element that was extracted from the splitting function, and then we can functionalize that if we want to, but you can take a look at that on your own. And the reverse operation, like if you have a date time object and you want to write it to a file or send it across the internet or do anything other outside your application with that object, then what you need to do is you need to convert it into a string, because data flows in the form of a string. So the reverse operation is called strf time. So we have strp time, which does the conversion from a string to a date time or date object, and we have strf time, which does the conversion from a date time or date object into a string, which you can then use to send to something else. So if here, for example, we're getting our date now, which is in the form of this format here, and rather this format, and we are saying convert this into a string with %m, %d, /%d, /%y. So we get %m slash %d slash %y, and then a space, and that's the space, and then hours, minutes, seconds, %h, %m, %s, and that comes here with colons in the middle. And notice we have the colon, so the colon comes here. If we don't have the colon, it's not going to come there, right? So just to clarify what this stuff is, if I change this to say this, for whatever reason, right, and I run this, then I'm actually going to see the YY over there, right? So the formatting is actually just taking exactly what we're giving it and replacing it by putting that in the string that we are using in the conversion from a date time to a string object. So that's the basics of the date time library.